Alright, so the final part of 4.4 we need to talk about is net change. This is like the word problems or the real world application of integrals. Like, why do I want to learn this? When am I ever going to use this in real life? 4.4 basically deals with this identity. On the top, it says if I integrate any rate of change, I get the net change. So remember, integration is adding up all of the y values. So if I add up all of the rates of change, I get the total amount of change between two times. So if you give me the rate at which turkeys are consumed on Thanksgiving, I can integrate it and find the total amount of turkeys that were ate. Or if you give me the rate at which a population is changing, I can integrate it and get the total amount of population change. Or down here, if you give me the rate at which something is moving, the rate at which its position is changing, aka velocity, I can get the net change in position. And a word you need to know, the net change in position is also called displacement. So integrating a rate gives me the total amount of change, which makes sense because I'm adding up all of the changes. If I add up all of the changes over a span of time, I get the total amount of change in that span of time. So we're just going to do a number of examples to start. So oil is leaking out of a pipe at a rate of R of t is equal to t squared plus 2t plus 5 gallons per minute. How much oil came out of the pipe from time equals 0 to time equals 6? Well, I can find the total change, which is how much oil came out, by integrating from 0 to 6 this function R of t with respect to time. So that's the integral from 0 to 6 of t squared plus 2t plus 5 dt. So using the fundamental theory of calculus, that's going to be big F of 6 minus big F of 0. To find big F, I find the antiderivative. Big F of t is 1/3 t cubed plus 2t squared plus 5t. So this is going to be equal to 108 plus 72 plus 30 minus big F of 0 is just 0. So the total amount of oil that came out is going to be 210 gallons of oil. Alright, so here's a problem where water is flowing into a holding tank at a rate of t squared minus 9 gallons per minute. What is the net change in the volume of the water in the tank in the first 10 minutes? Go ahead and set up an integral and find the number of gallons that went into the tank in the first 10 minutes. Alright, so I set up the integral from 0 to 10 because those are my times. I integrate the rate. I use the fundamental theory of calculus. I find the antiderivative, that's big F of t down here, and I get 730 over 3 gallons came into the tank. Now, the wording in this problem, it's a little bit ridiculous, but that's the whole point. To drive home, it doesn't matter what we're talking about. If you give me a rate, I can integrate it and find the total change. So, in this problem, pink elephants are eating peanuts at a rate of the square root of t plus t squared over 4 pounds per day. What is the total weight in pounds of peanuts the pink elephants ate in the first 4 days? So, regardless of what it is, if you give me a rate, I can integrate it to find the total amount. So, we're just going to set this one up, not do the integration. So, to find the total amount, it would be the difference in time, 0 to 4, of t to the 1/2 plus 1/4 t squared. I would integrate that, evaluate it, and have my answer. Now, initial conditions matter. In the beginning problems, all we were looking for was net change, so I just had to deal with the regular integral. Now, pay attention to the wording in this problem. A population of insects increases at a rate of 200 plus 10t plus t squared over 4 insects per day. Find the insect population after 3 days, assuming that there are 35 insects at time t equals 0. Alright, well, if I integrate this from 0 to 3, that's going to give me the total change in population for the first 3 days. But then I need to remember that there are 35 insects at t equals 0. So to set up that equation, I would say the total amount of insects after day 3 is going to be 35, the initial insects, plus the integral 0 to 3 of 200 plus 10t plus 1/4 t squared dt. Again, reading the problem is important and understanding the initial condition. Essentially, that 35 sort of is acting like our plus c. So this is going to be 35 plus big F of 3 minus big F of 0. To find big F of t is equal to 200t plus 5t squared plus 1/12 t cubed. So plugging that in, the insects are going to be 35 plus big F of 3 is going to be 600 plus 75 plus 27 over 12 minus big F of 0, which is 0. So I get 712 plus this extra 3/12, or I get 712.25 insects. Now, if this were an FRQ problem, we would want to say the answer is 712 insects. We don't round up or down, you just drop completely. If they want you to round up or down, they will specifically tell you in the problem. Otherwise, we say you can't have a quarter of an insect, just like you can't have a ninth of an insect or 3/4 of an insect, so you just drop it completely, and the insect population after 3 days is 712. Here's a velocity question. A particle's velocity is modeled by v of t is equal to t squared minus 2t minus 3. What is the change in position from time equals 0 to time equals 5? So we would set that up using this formula. The integral from t0 to t1 of v of t dt is equal to the change in position, which we also called the displacement. Go ahead and integrate that. I'll give you about a minute to find the answer to that problem. Here's the solution. I integrated from 0 to 5 the velocity. I found my antiderivative and I plugged in, and I would get positive 23 over 3. This would not have a units because there were not any units provided in the question. Here's a really tricky question about traffic flow using integrals and rates. So the traffic flow at an intersection is Q of t is equal to 3000 plus 2000 t plus 300 t squared. That's the rate at which cars go through an intersection, where t is in hours and t equals 0 is at 7 a.m. How many cars pass through the intersection from 8 a.m. to 10 p.m.? And a really common mistake in this problem is to set up the integral from 8 to 10. But that is not correct, because they tell you that t equals 0 is 7 a.m., which means that 8 a.m. would be t equals 1, and 10 a.m. would be t equals 3. So anytime you're dealing with a time of day, make sure that you're looking for this key piece of information, and that is, what is time equals 0? Give yourself a frame of reference. So go ahead and set up the integral, set up but do not solve the integral that tells me the total number of cars from t equals 1 to t equals 3. When a question asks you to set up but not integrate, all they're looking for is this. They want you to basically show them the limits, that's usually a point on an FRQ, and the thing that you're integrating. So if this were set up but do not evaluate, you would stop right there. Here's the second really important thing here. If I integrate velocity, that gives me the change in position or displacement. To get the total distance traveled, I need to find the absolute value of velocity, which means I need to take all the negative areas and make them positive. This is a lot easier to explain when I'm actually there, but to give you an idea of the differences, just follow the blue line. If we were talking about the blue line, it would start out at 0 and it traveled here to 8 meters and then all the way back to here. If I had the integral of velocity, it would give me the net change in position from the beginning to end. So the integral of velocity would be 3, because if you were to integrate that, it would give you positive 8 going this direction, but then negative 5 going back, and the change in position was only 3 meters. But if I was to do total distance traveled would give me 13, because it would be the positive 8 going to 8 and then the absolute value of negative 5, so positive 5 going back, so it would be positive 13. So the difference between change in position and total distance traveled is change in position is literally the distance between where it started at that time and where it ended. Total distance gives me the total amount that thing traveled. So when I see a particle's velocity is modeled by t squared minus 2t minus 3, what is the total distance traveled? Whenever I see that total distance traveled, it's like alarm bells going off in my head. Wait a second, does this thing go backwards? Is the velocity negative? I usually like to think about it in terms of the picture. Well, the velocity function is a parabola, and I care about its velocity from 0 to 5. So if I were to think about this parabola, it would be at negative 3, and then if I plug in 1, it would give me negative 4, and then when I plugged in 2, it gives me negative 3, and then when I plug in 3, I get 0, and then it sort of takes off from there. And because we're doing total distance traveled, I want to find the integral from 0 to 5 of the absolute value of velocity, which means it's like everything's above the x-axis. which means that I'm really finding the area under this blue curve. The area here and the area in here. So I need to set this into two separate areas. Here's your homework for tonight, and the answers will be on Edmodo this evening.